Welcome to the Azure Fundamentals AZ-900 training. In this video, we'll be looking at Module 1, which is to describe cloud computing. All right, let's get into it. The first chapter that we'll be looking at is to define cloud computing. So the question is, what is cloud computing? Microsoft defines it like this. Cloud computing is the ability to deliver computing services over the internet. In a typical traditional IT scenario, you will be accessing your virtual machines, your server locally. So when we look at traditional IT, we're looking at things like virtual machine. We're looking at things like storage, as in the space that you have on your servers or the space that you have for your databases. We're looking at databases, either SQL databases or no SQL databases. You're looking at networking. Yes, you're thinking of physical network cables going to switches and going to servers. This is what you would consider as your traditional IT infrastructure, your on-premise infrastructure. When we look at cloud, we're looking at accessing these resources over the internet. The idea of cloud-enabled IT comes into play, where you can access these same resources over the web. So instead of accessing virtual machines locally in your database, you'll be accessing it over the internet. Virtual machine, storage, your database, your networking. And not only can you access these typical traditional IT infrastructures, but with the cloud, it enables or it empowers you to access different sorts of technology as well, including things like Internet of Things. So you're thinking IoT devices. When you have certain smart devices that sync with the internet, the cloud makes this very possible. When you consider things like machine learning and the amount of resources you need in the sense of GPU or CPU that you require to run some of these machine learning and AI algorithms, it is a lot. When you have access to resources over the web, you can spin up virtual machines, you can spin up servers that can access and utilize these resources. You don't have to think of buying GPUs and CPUs, ordering it, and then stacking it up into your servers or into your infrastructure. You can access it practically instantly over the web. And that's the power of the cloud. Let's look a bit closer at traditional IT infrastructure and cloud-enabled IT infrastructure. There's one main thing to keep in mind. Your traditional IT infrastructure, you own these services. It's owned by your company, and you have full control of your resources. In a cloud-enabled environment, you are renting these services from a cloud service provider. In this case, Microsoft Azure. So in a traditional IT, the things that you purchase, if you purchase a server, if you purchase hard drives, if you purchase SSDs, you own the physical equipment and whatever services that come with it. When you think of cloud computing, are renting the services from the cloud service provider. So again, what is cloud computing? Simply accessing IT resources over the internet. Let's move on to chapter 2, and that is to describe the shared responsibility model. So what is the shared responsibility model? According to Microsoft, it is where responsibilities are shared between the cloud provider and the consumer. The are things that you as the consumer have to be mindful of. There are things that only you have control over, and there are things that the cloud service provider, in this case Azure, is mindful of, or the things that they have control over. There are things that you have to take care of that the cloud provider won't take care of for you. There are things that the cloud provider will be taking care of that you don't have to worry about. If we look at the shared responsibility model or chat, this is the chat from Microsoft, taken from Microsoft Learn. There are responsibilities that are always retained by the customer. Your information and data, it is solely your responsibility, and that is across the different cloud service types. So if we look, we'll see SaaS is a cloud service type, software as a service, PaaS, platform as a service, IaaS, infrastructure as a service, and then there's the on-premise or your traditional IT. We won't go through these cloud services right now. There'll be a later module for that, but let's just be mindful of software as a service. Think Microsoft 365 and the various softwares that they offer, and on-premise, think traditional IT. So when it comes to your information, your data, it is solely your responsibility. Whatever you're putting in the cloud environment, be it your documents, be it your images, be it your songs, your music, whatever it may be, that is yours and it belongs to you. Your device, your mobile or your PC, your physical device that you're using to interact with these cloud services, they are yours. They are your responsibility, and it is something that you and you alone will have control over. When you're looking at things like your account and identities, in other words, your username and your password, the cloud service providers might have various policies in place for ensuring your password is a certain length, ensuring that it has certain characters, and even two-factor authentication, where you have to use something like an additional application or a phone number to get access to the services. But this password, its username, it belongs to you. It remains your responsibility. You have to make sure that your passwords are secure. You have to make sure that you don't give people your passwords or give people access to your two-factor authentication, whatever it may be. You need to ensure that your identities remain secure, because that is something that you have complete and full control over. All right, so let's enter into the areas where the responsibilities now start to become shared. There are things that you have to be mindful of, there are things that the cloud provider has to be mindful of. Okay, the first thing is what you call identity and directory infrastructure. So again, I'd like you to imagine Microsoft 365. Let's take something like Outlook that you use to do your emails, for instance, right? There is an infrastructure in place when it comes to sending emails, when it comes to receiving emails, when it comes to junk emails, when it comes to spam, etc., that you don't have any, in a sense, control over. So from there, on the software as a service, something like Outlook, that responsibility now is shared. Yeah. So there are some emails that are coming through, and the infrastructure that organizes those emails, software provider, or in this case, the cloud provider, is responsible for it. Is responsible for maintaining that infrastructure that's there. At the same time, there are certain things that you have responsibility for. So you may then create certain folders, certain subfolders in your Outlook, however you want it to be, but you want to make sure that the next time you log in to Outlook, be it on the web or on the actual application, that those folders are still there. So there's things that are happening in the backend that software as a service provider, in this case your cloud provider, will focus in on. That would be shared between them and you. Now, if you look at on-premise, if you have your own mail server or you have your own mail application, that identity and directory infrastructure is your responsibility. You have to make sure that these things are there and these things are set up properly, and everything that persons use remain the way that they want it to be set up. So we can see, like, from this section, the responsibilities are shared. Right now, if you're thinking on-premise, I'm not going to take up these responsibilities right now. I'm sharing those responsibilities with the cloud service provider. Applications. In a software as a service, cloud service type, again, if you're looking at something like Outlook, that application, you don't have to worry about it. You don't have to worry about the code. You don't have to worry about it updating sometimes, because Microsoft pushes out updates regularly. You don't have to worry about the actual application. That is completely Microsoft's responsibility to make sure that it's patched, to make sure that it is secure, to make sure that the UI is in place, to make sure that it receives regular updates. You don't have to think about that at all. You just know you come on Outlook and you send your emails, you receive your emails. That is the responsibility, in the case of a software as a service, the responsibility of that provider. When we consider network controls, we can see that if we're looking at, again, an application like Outlook, the intricate networking that goes behind ensuring that your email goes from one place to the other, you're not responsible for that. Those network controls, again, is the responsibility of the cloud service provider. Let's look at the operating systems. You're accessing Outlook on the web. That back-end server that is hosting that Outlook application on the web, be it a Linux, be it a Windows server, whatever it may be, the operating system that is assisting in pushing out the application to you, you don't have any control of it. It's not your responsibility at all. It is the cloud service provider responsibility. Now let's get into the parts where the responsibility is solely that of the cloud service provider. What we're looking at is things like the physical host. Again, the physical server that Outlook is being hosted on, it's not your responsibility at all. It is the responsibility of the provider, of the cloud provider. If you consider the physical network, the physical cables that go in the switches, the physical cables that go into the devices, that's not your responsibility. That's the responsibility of the provider. And if you're looking at the physical data center, you're thinking AC, you're thinking UPS, you're thinking the physical security to enter and to get out of these particular buildings. That is not your responsibility. That is the responsibility of the cloud service provider. So as we can see, when you have to set up your applications, your infrastructure, your systems on-premise, everything you have to think of. You have to consider the security to your data center. You have to consider your physical devices. You have to consider your AC, your backups, etc. Everything is yours, your operating system, your applications, whatever it is. But when you enter into cloud computing, your responsibility is divided. So there are certain things that you give to the cloud service provider, and there are certain things that you remain responsible for. Now let's go into chapter 3, and that is to define cloud models within public, private, and hybrid. So what are cloud models? Well, Microsoft defines it as this. They are the deployment type for cloud resources. So when you are deploying cloud resources, cloud-enabled IT resources, there are some models that you can adopt. There are some deployment types that you can consider when you are engaging in the cloud computing landscape. There are 6 types of cloud models. Let's begin with the first type, and that is private cloud. So when you think of private cloud, the definition is simple. It is privately owned. You are the one that runs, operates that particular cloud environment. Your organization Your company operates that cloud environment. It is not public. It is not used by anyone else. It's only you and only you alone. The second type is the public cloud. The public cloud is publicly owned. So yes, the cloud service provider owns the data centers and infrastructure, etc. But they give you access to it. So in a public cloud, I can spin up a virtual machine, I can set it up, and that, in a sense, will be mine. It will be in a public cloud service provider's infrastructure, but this is my virtual machine. Same way you can do the exact same thing, and that would be yours. So in a public cloud, it is publicly owned. Everyone and anyone can purchase a part of that public cloud environment or infrastructure. The hybrid cloud is an interconnected environment. So that means that you have an on-premise environment or on-premise infrastructure, and you connect that to your public cloud. So you might have certain bursting requirements where the cloud is what absorbs that traffic. So if, let's say, you have a certain server and it gets an influx of traffic, then you can take that traffic and send it to the cloud, right? So you are interconnecting your on-premise with the public infrastructure. Then the fourth type is something called multi-cloud. So in multi-cloud, basically you're accessing multiple cloud service providers. Think Azure, think Google Cloud Platform, and Amazon Web Services. You're basically using more than one public clouds for your business needs. Azure also have something called Azure Arc. So the Azure Arc is you managing your private or public cloud infrastructure using an Azure service called Azure Arc. It's Azure Manage. So again, you could have a private cloud, you could have an on-premise infrastructure, and you could even have a public cloud, services from public clouds, and you can manage everything with this service called Azure Arc. So it's an Azure Managed cloud model. Number 6 is Azure VMware, and that is for VMware hosted environments. So if you have an environment where you already utilize VMware services, you already have a VMware infrastructure, then you can manage that VMware infrastructure in Azure or with Azure with a service called Azure VMware. And you can also migrate your on-premise VMware infrastructure to Azure as well and maintain that same VMware type infrastructure as you had on-premise. Okay, so let's get into chapter 4, and that is to identify appropriate use cases for each cloud model. The first cloud model that we'll be looking at is private cloud, privately owned. It is owned and operated by a single entity. So you have one entity, one organization, one company that has its own private cloud infrastructure. So imagine, the big companies. Imagine Coca-Cola. And Coca-Cola has its own team that develops a cloud infrastructure for Coca-Cola and for Coca-Cola only. That type of cloud is a private cloud. In a private cloud scenario, you have much greater control. In fact, you control it all, really. However, it also costs more, a much greater cost as well. If you're dealing with a private cloud, you have to consider things like AC. You have to consider things like the physical cables going to the switches or to the servers. You need to consider a lot more with a private cloud, and because of that, the cost of maintaining a private infrastructure is greater. In a private cloud, you have to pay for the electricity, and you have to pay for whatever maintenance task that you need to keep that infrastructure running. A public cloud is different. It is publicly owned, which means that anyone and everyone can utilize that cloud service. It is used by everyone. The cloud service provider builds, controls, and maintains that public cloud. So they're the ones that do maintenance on it. They're the ones that provide servicing of it. They're the ones that ensure that when someone connects to it, that they have the various resources available to be used by anyone that is using their service. The cost of a public cloud, it is relative to the usage. So when you think public cloud, think it is used by everyone and that you pay for what you use. When we get into hybrid cloud, the interconnected environment is both a public and private cloud usage. So again, your private cloud, it could be on-premise, and you can extend whatever resources that you have to the public cloud. It can have a constant private usage in the case of your private cloud and a temporary public usage. So again, if you only need the public cloud for bursting capabilities, you have a high influx of traffic coming to your web servers during the Christmas season, for instance, then during the Christmas time, you could spin up some cloud servers, cloud resources, and you can have that additional resources go to the public cloud, right? While you maintain your on-premise infrastructure for your regular day-to-day usage. So it's an interconnected environment there. When you're dealing with multi-cloud, multiple cloud service providers, it is actually a very likely and a very popular scenario to be. Forbes published a research that states that 90% of large organizations are multi-cloud. A lot of organizations realize that one cloud provider, the single point of failure. By having multiple cloud providers, you reduce that single point of failure, and you also have the ability to use the various resources that you will find on these different cloud providers. So you're using multiple cloud providers, Azure, AWS, Google Cloud Platform, and one provider might have one feature that is less costly, or they might have one feature that is better for that particular thing that you want to do. So multi-cloud is very popular, and it is something that most organizations, large organizations, definitely utilize. When we get into Azure Arc, it is used for central control. Again, it could be private, it could be public, it could be a different cloud provider altogether, and manage it with Azure Arc. You can manage your cloud environment with that particular cloud model. Azure VMware, it is used for VMware private cloud, specifically VMware workloads. If you have VMware workloads, then you utilize Azure VMware to maintain, rule those VMware workloads. All right, let's go to chapter 5, and that is to describe the consumption-based model. So, what is the consumption-based model? The consumption-based model can be described like this. You pay for the IT resources that use. And don't use any IT resources in a particular month, you don't pay for those resources. So that's the consumption-based model right there. You pay for the IT resources that you use. The consumption-based model is based off the OPEX model, or it stems from the OPEX model. When you're thinking of OPEX, you're thinking of operational expenditure. So OPEX is operational expenditure, whereas CAPEX is capital expenditure. OPEX is spending money on services or products over time. It is used in an operational way. So think of renting, think of your electricity bill or your water bill, think of renting a vehicle. That is operational expenditure. Capital expenditure, on the other hand, is a one-time cost. It's a one-time purchase. Usually it's an upfront cost for the tangible resource, and you don't pay for that particular thing again. It's already yours. It's a one-time cost. So think of a new building, a one-time purchase. Think of a vehicle again, but as a one-time purchase. These are capital expenditures, usually a one-time cost. Consumption-based model operates under the operational expenditure type of model. Now, I'd like to compare and contrast the consumption-based model with the subscription-based model. Now, both the subscription-based and the consumption-based fall under the OPEX model of spending, but the consumption-based model is not a subscription. But even if they might be on the outside subscription-like features for consumption-based models, but it is something different. So for consumption-based model, you pay for actual usage, but in a subscription-based model, you pay a fixed fee for a set of packages or services. What do I mean by that? Let's think of Netflix. If you have Netflix, there are different packages. What you pay on a monthly basis is based on the package that you have. If you look at Microsoft 365 and the various subscription packages, what you pay is that specific package with the features, with its limitations, with whatever resources that you have access to, as you pay that fixed price every single month. Consumption-based model is highly scalable. You can adjust usage as needed. So if you're using 100 gigabytes of storage in a particular month, and the next month you need to use 10,000 gigabytes of storage, you can. It is highly scalable. You can go up with your consumption, or you can reduce your consumption. A subscription-based model, on the other hand, whatever resources you have, they are limited to the package that you paid for. So going back on Microsoft 365, if you paid for a particular subscription that is allowing you to only save 500 gigabytes of storage, then that is the package that you have. That's your limit. You cannot go above that. But to go above that, you need to upgrade your subscription. In a consumption-based model, you can go up or go down as like. Now, with the consumption-based model, your spending, it's a less predictable in the sense of, if let's say you have a web server, and based on your web server, you have, let's say, a lot of people coming in this week, less people coming in next week, a lot of people coming in the week after that, a lot of people coming in the week after that, then your bill for that month on a cloud service provider might be a lot different than another month where you have a lot of people coming in 1 week and then no one else coming in for the other 3 weeks. So the cost that you have to pay is less predictable. It varies based on how you use it. Whereas with a subscription-based model, if you think of something like WordPress, for instance, you know that whatever cost that you are spending on your WordPress site, it is a fixed cost. If no one comes to your website, then you still have to pay that whatever amount is. If a lot more people come on your website of whatever subscription package that you have purchased, then you still pay the same cost. A consumption-based model have variable workloads and temporary spikes. So you can welcome in variable workloads when you have a consumption-based model. With a consumption-based model, it allows you to take in a lot more information, a lot more data, a lot more traffic, a lot more resources. And the workload that you have, whatever it may be, it can expand based on whatever is coming in. And it can take in temporary spikes. You're taking 100 users, it can go up to 1,000 users and then come back down. it welcomes that type of uncertainty and variation in whatever resources that you're giving it. A subscription-based model, on the other hand, steady workloads with predictable usage. Whatever you pay for, it, in a sense, better be the type of things that it receives. Whatever that you're paying for, it has to be that within your package. If it goes out of it, then you won't be able to see that benefit. The consumption-based model has several benefits. If we start to look at some of those benefits, one of the first things that we see is that there is no upfront cost. If, let's say, you spin up a virtual machine, you don't pay for that virtual machine that you just provisioned. There's no upfront cost. When you do pay is at the end of your billing cycle. And when you're done using that particular virtual machine, you can turn it off and you will not be charged in that next billing cycle. So there's no upfront cost. There is no need to purchase any infrastructure. You just rent out those infrastructure usage. You can access more resources as needed. That is one of the number one benefits of cloud service providers and this consumption-based model. And then you can stop the resources. As I said, you're done using these resources, you can stop it and you won't be charged. Let's get into chapter 6, and that is to compare the cloud pricing model. So again, what is cloud pricing model? Well, the cloud pricing model can be defined as the various options that you pay for cloud services. So there are several ways that you can pay for these cloud services that Azure is providing. With Azure, there are 6 pricing models. There is the pay-as-you-go model. There's a dev or testing price and prices that they give you. There is the free tier pricing, or the free tier benefits, I would say. There's spot pricing. There's a hybrid benefits. And there is a reserved pricing. All right, now let's look at each of these in turn. Starting with the pay-as-you-go pricing model, you are charged for what you use. If you use a set of storage, whatever you use, that's what you will be paid for. The prices are determined per hour or per minute. So some services that Azure has, they'll tell you X amount per hour or X amount per minute. And there are pricing calculators that you can use to estimate how much this particular resource will cost over X amount of time. But with a pay-as-you-go model, you are charged for using this resource for an hour, this resource for a minute, and if you use it for X amount of hours, you'll be charged X amount of dollars. Again, with a pay-as-you-go pricing model, there's no upfront cost. You start up the service, you get it running, you get whatever benefits you want from it, and then at the end of that billing cycle, pay. Users on a pay-as-you-go pricing model can scale the services up or down as needed. And you can also monitor this cost in real time. So Azure has several services that you can use to monitor your Azure resources, and you can actually see what you're using, and you can actually see what you have forecasted to as well. There is the reserved instances. So a reserved instance is for a specific term. So imagine you have a virtual machine and you want to use that particular virtual machine, this amount of resources associated with the virtual machine, RAM, storage, network, etc., for you, or for free use, whatever that term is, are committed to using that particular resource for a specific time. And you have reserved instances, then the price that you are paying, the rate that you are paying, is reduced. So with reserved instances, you receive a discount rate for the committed resource. So in other words, Azure knows that they don't have to think or consider, using this particular resource for this other customer or that other customer. They know that this resource is going to be for you for the next year or to the next 3 years. And because of that long-term commitment, they will reduce the price for you. The next model is hybrid benefits. So if you have an existing on-premise server traditional IT infrastructure, then most likely you have certain licenses, be it Microsoft licensing in Windows Server or SQL, or even Linux licensing as well with Red Hat and the other services there. With hybrid benefits, you are taking those and you can utilize them in your cloud environment as well. There is also spot pricing. So spot pricing is when you have access to unused Azure compute capacity. So what that means is if there are compute resources that are just hanging around, they are not being used, maybe there's a slow season in Azure and these resources are just hanging there, instead of it, just being unused, what Azure will do is that they will reduce the cost for you. So you'll have significant cost savings because the cost for these resources at a different time might be a lot more expensive. So they would reduce that cost for you and you will use it for your environment. Because you are using this resource that would typically be used otherwise, it is for temporary use case. It is not meant for a production environment. Why? Because Azure can utilize those resources at any time. So again, just imagine you have a slow season, Azure has a slow season, and those resources that are there, they are in excess, they will give it to you at a reduced price. But if things start to pick up again and clients are asking for this specific resource that you have at a reduced price, then Azure can reclaim those resources at any time. They will obviously let you know that they will be reclaiming that resource, but they can at any time. So generally speaking, temporary use cases, test environments, etc., you can utilize the spot pricing and get a lot of benefits for whatever that you want. The dev or test pricing model is for development or test workloads. So because you are utilizing resources or workloads in a development sense or in a test sense, you will receive reduced pricing. The caveat to that is that you need to have what is called a Visual Studio subscription. So this is for mostly coding, development work. So if you are developing an application, you're developing a software, whatever it is, and you have a Visual Studio subscription, then you can utilize this dev test pricing for your workloads to test your environment, to break it, etc. So that that it is up and running before it goes into production. But you need that Visual Studio subscription, and then you'll be able to access these types of pricing. And then you have the free tier. So the free tier is free. So there are free services that you can utilize in Azure up to 12 months. And these services are obviously limited. So you're not going to have all of Azure services, but you'll have a good amount of services actually that you can use for free for up to 12 months. There is no commitments when using these services. You can spin them up, drop them down, and sign out at any time if you like. The last chapter that we'll be looking at is serverless. So what is serverless? Serverless can be defined as building, deploying, operating applications without infrastructure. So I put an asterisk next to infrastructure because infrastructure is present. There is some infrastructure involved when it comes to making sure the service works, but it is abstracted from the user. It is abstracted from you. So the only thing you need to focus on is on writing the code. The only thing you have to focus on is on the development process to get that application or software up and running. Let's compare serverless applications to server-based application. So in a server-based application, you need to consider your operating system. Are you using a Linux-based system? Are you using a Windows-based system? You need to consider your virtual machines or servers that you'll be hosting that operating system on. You need to consider networking aspects. With the networking, what type of speed that you are going in and out of that particular server. You need to consider the actual storage. Are you using SSDs? Are you using HDDs? What type of storage does that physical infrastructure have? You need to consider scaling. Are you going to have this particular application run on this environment with X amount of users? What if you get double that? What if you get triple that? What happens? Do you have excess capacity to sustain a spike in usage? So all of this you have to consider when you're looking at a server-based application. When you're looking at a serverless application, the only thing you really have to consider is the code or the functions, whatever snippet of code that you have or that you want to run when certain actions go. That really is the only thing you need to worry about when dealing with serverless applications. When we think of serverless computing, consider functions. Functions are snippets of code. It is small bite-sized pieces of code that you want to be executed when something happens, right? So when we look at functions, we've been introduced to something called function as a service. So function as a service is where the cloud service provider, they provide the infrastructure, they give you everything that you need under the hood. And the only thing you need to do is focus on the code. Focus on whatever you want to be executed. Again, the CSP, they provision it, they give you the scaling, they manage everything. But the only thing you have to focus on is the code. Function as a service is you being able to plug in this particular code when this happens, so that this other thing will happen. So because of that, you can focus on the business logic. You can focus on adding particular value to your organization because the back end is abstracted from you. You only focus on that code. In Azure, the function as a service offering is called Azure Functions. This particular offering is event driven. So you have an event driven computer experience. Again, if you have a resource that you want to be executed, you want to have something acted on, you can add a function between the two. So when this happens, the function is executed and then something else is the result. With Azure Functions, you only pay for the time your code is executed. So if your code takes a second to get executed, that's what you pay for. In summary, from chapter 1 to chapter 7, define cloud computing. We defined it as delivering computing services over the internet. Chapter 2, we described the shared responsibility model. And we said that that's when the responsibilities are shared between the cloud provider and the consumer. Chapter 3 was to define cloud models. And we said that that is the deployment type for cloud sources. Chapter 4, we identified the appropriate use case for each cloud model. And we looked at them individually: the private cloud, public cloud, the hybrid cloud, the multi-cloud, Azure Arc, and Azure VMware. Chapter 5, we described the consumption-based model, and we said that that is when you pay for the IT resources that you use. The consumption model is not the subscription model. Chapter 6, we compared the cloud pricing model. So we looked at various options to pay for cloud services: pay as you go, reserved instances, hybrid benefits, spot pricing. There's a dev test pricing, and then there's the free tier. And finally, we looked at serverless, and we said that serverless is to build, deploy, and operate application without infrastructure. And we explained that infrastructure is present, just abstracted from the user. Azure Functions is the function as a service offering from the Azure Public Cloud. Thank you for watching the first module in the Azure Fundamentals series. If you enjoyed this module, be sure to like this video and leave a comment in the comment section. Let me know what you liked about it. Let me know whatever you need clarity on. If you haven't already, be sure to subscribe to this YouTube channel. I will see you in the next video.